So this is the question number 15 of yesterday's paper, combined maths paper. So let's see how you can do this sum. This part you have to you are given an identity. So we have to find the constant A, B, C. So this is the identity: x squared plus x plus 2 equals A times x squared plus x plus 1 bx plus c times x plus y. Right? Now you can equate the coefficients on both sides. So if you equate the coefficient of x squared, left hand side coefficient of x squared is 1, right hand side is a plus b. If you equate the coefficient of x, left hand side coefficient of x is 1, right hand side coefficient of x is a plus b, a plus b plus c, a plus b plus c. Then from these two you will get c equals 0. C equals 0. Then you get the coefficient of x to the 0, that is a constant term. Left hand side constant term is 2 and right hand side a plus c. Now c is 0, therefore a equals to therefore if a equals to b equals minus 1. Now you can rewrite the identity by substituting this constant equals 2 into x squared plus x plus 1 plus c is 0, b is minus 1, so minus x times x plus 1. So this is the identity, but hence write down the partial fractions of this equation. Now you can divide both sides by x squared plus x plus 1 into x plus 1, right? So x squared plus x plus 2 over x squared plus x plus 1 times x plus 1. So each term you divide by this term, is x plus x plus 1 into x plus 1 minus x into x plus 1 over x squared plus x plus 1 into x plus 1. Now this term gets cancelled and this term gets cancelled. Now you can have, these are the partial fractions. One term is 2 over x plus 1 minus other term is x over x squared plus x plus 1. Like that. So these are the partial fractions. Thereby you have to find the integration of this integration. You can find very easily. But if you integrate this one, this is 2 over x plus 1 is easily integrable, but x over x squared plus x plus 1 you need further arrangements for this term, right? So 2 over x plus 1, so you can write so partial fraction is over from this point. Now you can further you can separate this term so that this term is integrable. So you just multiply by 2 and divide by 2, you get this one. Right? What is the differentiation of denominator? Differentiation of x squared plus x plus 1 is 2x plus 1. So you have to form that term in the top. Right? So 2x plus 1, if you add 1, you have to subtract 1. Then 2 over x plus 1 minus half into 2x plus 1 over x squared plus x plus 1. Here minus into minus becomes plus, half times 1 over x plus 1. Further you can simplify this. So you can complete perfect square for this. 2 over x plus 1 minus half into 2x plus 1 over x squared plus 1 plus half times. You can complete perfect square for this one. X plus half 40 squared minus minus 3 over 4, that is this is 1 minus 1, this equals 3 over 4. Now this in integrable form. Therefore integration of this function, this over x squared plus x plus 1 times x plus 1 dx equals 2 over 1 over x plus 1 dx minus half times 2x plus 1 over x squared plus x plus 1 dx plus half times 1 over x plus half squared plus 3 by 4 dx. Now how do you integrate this function? So this part is easily integrable. So this equals denominator of differentiation of denominator is 1. It is in the top. Straight away you can write this equals 2 ln n plus 1. This also differentiation of the denominator is in the numerator. So this equals ln x squared plus x plus 1. This is tan inverse x. Half into 1 over 2 over root 3. Tan inverse 2 x plus half over root 3 plus 1. So this equals 2 ln x plus 1 minus half ln x squared plus x plus 1 plus 1 over root 3 times tan inverse 2x plus 1 over root 3 plus C is an arbitrary constant, right? So this is the answer for that part. Let's see what is next one. So this one, X, you have to do part B. Then part B show that you just take y1 plus sine 2x. So this equals 1 plus cos pi by 2 minus 2x. Then you can put in half angles 1 plus 2 cos squared pi by 4 minus x minus 1. So this equals to cos squared pi by 4 minus x. Okay. Then you have to find this integral. We have to integrate this function from 0 to pi by 2, 0 to pi by 2, 1 over 1 plus sine 2x dx. So this equals 0 to pi by 2, 0 to pi by 2. So instead of 1 plus sine 2x, you can put 2 cos squared pi by 4 minus x dx. So this equals 0 to pi by 2 half sec squared pi by 4 minus x. So this equals half tan pi by 4 minus x divided by minus 1. Now you have substitute limits from 0 to pi by 2. So this equals half into minus 1 times tan pi by 4 tan minus pi by 4 minus tan pi by 4. So this equals half into minus 1 into minus 1 minus 1. So this equal to 1. So therefore, from 0 to pi by 2, 1 over 1 plus sine 2x dx equals to 1. Right, let's see what's next part. If we take next part, now you are doing this one. I equals 0 to pi by 2 x squared plus 2x over 1 plus sine 2x whole thing squared dx. So using integration by parts, so you have to prepare this step before integration by parts. Okay. So you take like this, you just integrate this one d over dx. You just differentiate this one. 1 plus sine 2x to the power of minus 1. If you differentiate this one, this equals minus 1. 1 plus sine 2x to the minus 2 into 2 cos 2x. 2 cos 2x. Right? So this equals minus 2 cos 2x over 1 plus sine 2x over t square. Right? Now instead of this part, you can put with minus sign also. So leaving x squared, this part, instead of this part, you can put minus d over dx 1 plus sine 2x minus 1 divided by minus 2. So you can prepare this step. So differentiation of this part is equal to cos 2x over 1 plus sine 2x over t square. Now you can apply integration by parts. So x squared into 1 plus sine 2x to the minus 1 or minus 2. So you can apply limits for this. 0 to pi by 2 minus 1 plus 2x times 1 plus sine 2x to the power of minus 1 or minus 2 dx. If you apply limits for this one, this pi squared over 4 into pi by 2, substitute pi by 2 is 1 minus, if we apply 0 for this, we 0 to pi by 2. So this equals plus 0 pi by 2 x over 1 plus sine 2x dx. So you can take this part is j. So this equals minus pi squared over 8 plus d. Okay. Right. Then next part is we have to evaluate j. using the result of B, evaluate J and show that I equals this. And you can use the formula, integration property, the famous integration property, when you evaluate J. So J equals 0 to pi by 2 x over 1 plus sine 2x dx. So if we use this from 0 to a fx equals from 0 to a minus x dx. So using this result, you can take this equal from 0 to pi by 2 minus x over 1 plus sine 2 into pi by 2 minus x. Okay. So this equal from 0 to pi by 2 pi by 2 minus x. So again 1 plus sine pi minus 2x is just sine 2x dx. Okay. Now you can separate into two integrations. Then j equals pi by 2 1 over 1 plus sine 2x dx minus 0 to pi by 2 x over 1 plus. So this is j again. Therefore 2j equals pi by 2. But from the previous case, from part B, you have this value of this one is 1. So pi by 2 into 1. Then j equals pi by 4. If j equals pi by 4, now you can evaluate I. So I equals minus 5 squared or 8 plus pi by 4. So this equals pi by 4 you can take out 1 minus pi by 2. 1 minus pi by 2. That is the complete answer for this.